Basic components of new energy vehicles. Based on different energy sources. New energy vehicles can be divided into three types: pure electric vehicles, plug-in hybrid vehicles, and fuel cell vehicles. Pure electric vehicles. Pure electric vehicles are vehicles that use power batteries as their sole power source, a vehicle that is completely powered by an electric motor. Pure electric vehicles have a simple structure, and their production process is relatively mature. They are currently the main force in new energy vehicles. A pure electric vehicle primarily consists of an onboard energy system, drive motor system, auxiliary system, and safety protection systems. Onboard energy system. This is the device that provides energy to the vehicle, mainly composed of the power battery, battery management system, and the charging device. Compared to the charging device and battery management system, the power battery is the core of the vehicle's energy system. Due to the power battery's high energy storage quality and volume, it has a decisive impact on the performance of pure electric vehicles and range. Currently, power batteries used in pure electric vehicles, mainly lithium-ion batteries. Lithium-ion batteries are named after the base material they are made of. It's actually a concentration difference battery because during the charge and discharge process of a lithium-ion battery, only ions move between the positive and negative electrodes. No side reactions occur. This results in very high ion charging efficiency. It can also be made into a completely enclosed structure. Although lithium-ion batteries are made from a variety of materials, lithium-ion batteries are currently automotive lithium batteries are primarily lithium iron phosphate batteries and ternary polymer batteries. Both have long cycle lives. Advantages include good thermal stability. However, lithium iron phosphate batteries have the following disadvantages: poor low temperature performance. There is an urgent need to improve battery temperature management. Currently, lithium iron phosphate batteries are primarily used in commercial electric vehicles. Ternary lithium batteries are susceptible to thermal decomposition. Overcharge and discharge protection and over-temperature protection are required. Protection and overcurrent protection, increasingly used in electric vehicles. Battery management systems provide communication for power batteries. Safety and management control ensures the safe and reliable operation of the vehicle's power system. Charging device. It is the energy supply device for pure electric vehicles. It transfers energy from an external power source into the power battery, thereby providing the vehicle with a continuous supply of power. The drive motor system primarily consists of the vehicle controller, motor controller, drive motor, and components such as the mechanical transmission device. In actual operation, the vehicle controller receives and processes various signals, issues control commands based on the driver's intentions. The motor controller responds positively to the commands, controls the drive motor. The drive motor transmits the drive torque to the wheels via a mechanical transmission. Achieving vehicle forward movement, reverse, and other functions. Auxiliary systems for pure electric vehicles, including auxiliary power sources, air conditioning system, power steering system, wiper, lighting, and defroster, cooling system, heating system, etc. The auxiliary power source primarily consists of a DC converter and auxiliary power supply. Powers the steering system. Provides power for other auxiliary equipment such as the air conditioner. In addition, the braking system. The vacuum required by the vacuum booster. In conventional vehicles, this vacuum comes from the engine intake bulge. However, in electric vehicles, a dedicated electric vacuum pump is required. Due to the presence of high voltage in pure electric vehicles, safety issues cannot be ignored. The maintenance switch setting, and a series of vehicle-specific design features. Electrical protection measures. All of these are considered safety protection systems. Ensures the safety of drivers, passengers, and maintenance personnel. Plug-in hybrid vehicles. Compared to conventional hybrid vehicles, power batteries in plug-in hybrid vehicles, larger capacity and size, can also be charged from an external power source. The vehicle can be driven in pure electric mode. If the battery is depleted, it can also switch to internal combustion engine mode and timely charging of the battery. Clearly, plug-in hybrid vehicles both address the current problem of pure electric vehicles, of insufficient range, while also meeting the requirements of pure electric driving. and address the need for energy conservation and environmental protection. This achieves the complementary advantages of internal combustion engine power and pure electric power. Plug-in hybrid vehicles typically feature the engine drives the electric motor, power coupling devices, etc. Some models also feature dual electric motors. One motor drives the vehicle, the other is used to generate electricity to replenish the battery. Plug-in hybrid vehicle drive system. Relatively complex. By structural type, it can be divided into series hybrid systems, fixed coupled hybrid systems, and hybrid coupled systems. Each of these driving modes has its own advantages and disadvantages. The choice should be based on actual needs to achieve plug-in hybrid power. The optimal combination of high economy, energy conservation, and environmental protection. Fuel cell electric vehicles. This article focuses on hydrogen fuel cell electric vehicles. Hydrogen fuel cell electric vehicles uses hydrogen as fuel through an electrochemical reaction with oxygen, generates electricity to power a car. Specifically, this is in the fuel cell installed in the car. Hydrogen as fuel, with oxygen in the air, produces a redox chemical reaction, generates electricity. Drives the drive motor, thus it drives the vehicle. Because the byproduct of the fuel cell reaction is water, it is therefore extremely environmentally friendly. Compared to pure electric vehicles, the power source for fuel cell electric vehicles is onboard fuel cell system. However, fuel cells are not yet fully capable of meeting the challenges of a single propulsion source. The heavy responsibility of a single propulsion source, a battery pack is required, or supercapacitors as auxiliary energy systems, provide reasonable energy, supplement and assist. Hydrogen fuel cell electric vehicles are mainly composed of fuel cells, high-pressure hydrogen storage devices, power battery, drive motor, motor controller, and cooling device, etc. Because hydrogen fuel cell electric vehicles do not produce harmful emissions, and its energy conversion efficiency is 2 to 3 times higher than traditional internal combustion engines. Range. It also lacks the limitations of pure electric vehicles. It is truly ideal. An energy-saving and environmentally friendly new energy vehicle.